So welcome now to the third episode of mine from Lawrence Harvey's Tech Talk series, and I'm delighted to be welcomed by or joined by our third guest, Auryn Macmillan, who is founder and or founder of Gnosis Guild and Enclave. So thank you very much for joining me, Auryn. How are you?
Yeah, doing well, Ed. Thanks for having me.
No problem at all. Thanks for joining me. So yeah, I guess always to kick things off, I've just introed you a little bit, but if you could give a very, very brief introduction yourself into yourself, and once again, we were just talking off air about your route from basketball into blockchain. So it'd be awesome, like I said, to get an intro. And how on earth does someone go from professional basketball to founder of Gnosis Guild?
Yeah, it's a pretty odd career transition, I guess. Yeah, so I guess Hey everyone, I'm Auryn. Founder of Gnosis Guild. We are a venture studio and kind of autonomous core contributor to a handful of protocols and projects. I think most well known for a project we've been working on since inception called Zodiac. This is modular tooling for on-chain accounts. I think a good succinct way to talk about what Gnosis Guild is at a really high level is just a bunch of access control nodes. We really enjoy access control problems, on-chain access control problems, and so most of what we've done boils down to this in some shape or form. Zodiac is a particularly explicit expression of this, though, where it's a whole bunch of different modular tooling that plugs into the safe and then various other systems to just really enhance and change the way that access control works on chain, particularly for kind of highly secure protocols and large treasuries and all this good stuff.
Mm-hmm.
The backstory on how I got into Web3 from basketball. I mean, I guess the succinct way to talk about this is just I've always been a closet nerd, always a self-taught nerd, even while I was playing ball and kind of my whole career pathway through sports. In my downtime, I was still pulling apart computers and quietly hacking away on things. I don't know, my dad bought our first home computer when I was maybe 10 or something like that. And I started pulling that apart immediately and figuring out how it worked on the inside and writing bits and pieces of code and all this kind of stuff. So yeah, I've just always been a bit of a self-taught hacker. And I guess that passion really, I don't know, took off in the background while I was playing sports after falling down the Bitcoin rabbit hole in about 2013, and then discovered the idea of Ethereum pretty shortly after that, and that just kind of blew my mind. I think that the real kind of catalyst there was just this idea of, at the time, digital autonomous corporations. Now people call them DAOs, digital autonomous organizations. But really, for me, just like this idea of being able to encode organizational logic as a program, in addition to or as an alternate to legal encoding, it was just mind blowing. And so that is the thing that really got me excited about Web3, about the potential of it, both the potential to kind of radically lower the barrier to entry to cooperation and coordination in terms of organizations, but then also the other side of it, radically kind of raise the ceiling on kind of scalability of organization. The idea of organizations that are many kind of disparate individuals that are contributing to some outcome based on a system of programmatically enforced incentives, as opposed to kind of a hierarchical organizational structure or in addition to that. I think, again, just mind-blowing concept. And so that kind of drew me in, and then slowly the kind of balance of mindshare from sports to Web3 just like inverted, and eventually I just kind of left basketball altogether and just went full-time into Web3.
Yeah. Any transferable skills at all that have helped you out, or are they completely chalk and cheese?
No. Actually, I think there's quite a bit that transfers well. I mean, being able to public speaking and things like this for my kind of role, obviously, transfers well, being able to get up in front of a crowd and not be sweating too hard. It's, getting up and talking at a conference feels relatively straightforward after being in a stadium with 20,000 hostile fans. And this kind of thing.
Slightly friendlier, hopefully, at those conferences.
There's a whole lot less booing, which much friendlier. So that kind of stuff I think transfers well. Obviously, like being able to work as a cohesive part of a team, I think transfers really well. And then just approaching things as games, I think transfers really well to blockchain kind of Web3 based systems in particular. Thinking about everything as essentially gamified systems and kind of systems thinking. And maybe this is a bit of transfer going both ways here in terms of how I approached basketball as well. Coming from a background of being obsessed with computing and kind of thinking about everything in this type of setting. But yeah, I think there's a fair bit of cross-pollination between the two. Obviously, I sit in front of a laptop a lot more now. That doesn't transfer well to trying to get back on a basketball court. When I do try to get back out on the court now, I don't jump as high and much less fit. But I think there was a more skill crossover than what's immediately obvious.
I could imagine. So how did it come around? Obviously you founded Gnosis Guild, but that's a spin out of Gnosis, right? So did you join there first, and how did suddenly you begin founding the Gnosis Guild and its sort of subsequent projects?
So I originally helped Gnosis out around 2017, just to kind of bootstrap the community in advance of Gnosis doing its token launch, and then came back to Gnosis in 2020. I'm really bad with timelines, so I could be butchering something here, but roughly within a year or two of whatever stated time. And originally came in to do product management and kind of lead the conditional tokens framework. This was the underlying technology for the various prediction markets that Gnosis was working on at the time, still the underlying technology for things like Polymarket and SIA and a handful of other prediction markets that are still live. And eventually we decided to wind down support for the conditional tokens framework internally at Gnosis. And so I shifted focus then to designing and implementing the infrastructure for the Gnosis DAO. Internally, we'd had this goal to spin up the Gnosis DAO and kind of migrate the treasury from GmbH over to this on-chain entity, and needed the infrastructure to do that. And so this was the kind of mandate internally by which we ended up spinning up Gnosis Guild as a team. What do we want this infrastructure to look like? How do we design the on-chain representation of this organization? And in going through that design process, we arrived at a handful of different, essentially best practices on modular on-chain accounts, or just on kind of on-chain entities in general. Modularity was a big part of what we saw as kind of best practice there. Just recognizing that most organizations are not static, right? They grow and evolve over time as they have differing needs and differing personnel and differing objectives and all this kind of stuff. And so the idea of being able to instantiate a like static on-chain representation of this dynamic entity kind of conflicted. And so this was one of the really kind of core realizations that we had, is that if we wanted an on-chain entity to be able to properly map to its off-chain counterparts, it needed to be dynamic in the same way. And so Zodiac is an expression of this. It's this modular set of tools that can grow and adapt, or enable your organization on chain to grow and adapt over time to whatever the kind of changing requirements are. And so then, we spent the next couple of years internally at Gnosis doing essentially needs-driven development for the Gnosis DAO, building out modular tooling, kind of expanding this ecosystem of Zodiac modules for the safe, and then a whole bunch of other supporting tooling. And in doing so, built up some great relationships with other organizations then that had started leveraging the tooling as well. And so eventually decided to spin Gnosis Guild out from Gnosis just to allow it to interact a bit more autonomously with this ecosystem that it had created, and then to start operating as a bit more of a venture studio as well in its own right. And so then, yeah, we've now been independent for almost 2 years, which is wild, actually. Yeah, coming up on the second birthday, which is cool. And yeah, the other major project that we're working on at the moment is Enclave, which is this protocol for encrypted execution environments or collaborative confidential compute. And this is a really, really fun one, operating at the intersection of a handful of different kind of bleeding edge cryptographic methods. But yeah, a fun project, and we can dive into that more, I guess, later.
Yeah, definitely keen to. So first of all, obviously you kicked off with the Zodiac project. I know you've touched upon it there. You know, you're spinning out new projects like Enclave, for example. Where are you at with Zodiac, or where is it today?
Yeah, so Zodiac has, I guess, just been kind of quietly progressing. The main focus for Zodiac has been on this roles module, where we've had several iterations of it, both on the contract side and then on the supporting infrastructure. But this is essentially a module for fine-grained role-based access control. So you plug it into your safe. The safe is what we call an avatar for the organization. So it's the thing that holds funds, interacts with external systems, and then you plug modules into it to change how it behaves. And so this roles module lets you define arbitrary roles, assign those to, or assign role members to those roles. So addresses can become members of any given role. And then for any given role, you can arbitrarily define the set of addresses that role members are allowed to trigger the safe to interact with, along with kind of scoping down as tightly as you want there to enabling specific target addresses, specific function signatures on that target address, specific parameters on those function signatures on those target addresses, along with all kinds of different comparisons between the parameters and things like allowances and rate limits and all this kind of stuff. So very, very fine-grained, expressive role-based access control, which can be used in a variety of different ways. One of the core use cases that informed the design of it was for non-custodial treasury management. So organizations like Karpathy that do treasury management for a bunch of the largest on-chain treasuries. I should stop calling them Karpathy, they're now KPK. So KPK does this non-custodial treasury management, and this is all facilitated by the roles mod. Essentially, they set up a very tightly scoped set of roles that let them do their treasury management operations. So things like rotating between different yield-bearing opportunities, but does not let them arbitrarily abscond with the funds. So they can do their treasury management operations in a way that doesn't require them to take custody of the assets and does not give them arbitrary scope to do malicious or damaging actions on the treasury. And then, beyond that, a whole bunch of other use cases, things like the Gnosis Pay card. This uses a combination of the roles mod and the delay mod to enable the payment processor to spend funds on behalf of the card holder. We have a handful of other projects that are using the roles mod to enable, say, their security council to hit a pause button if something goes wrong, and all kinds of use cases like this. Again, general purpose on-chain role-based access control is the kind of core feature there, and this has been a large part of the focus recently. We are at the moment doing some work to make a bit more of a unified interface to make interacting with a lot of these tools much easier. You can see the first version of this at pilot.gnosisguild.org, and this is a Chrome extension that actually is super cool the way it works under the hood. It you basically can set up an arbitrary route between a safe that you want to act as, a role, and then your a module, and then your EOA, and you can have these kind of, yeah, again, relatively complex routes. The Chrome extension will kind of is able to understand what the route is. It'll inject the safe into whatever application you're trying to interact with. And then the really cool thing is, so it one lets you just kind of treat any application as if you're logged in with your typical browser-based wallet like MetaMask, but to inject any safe-based contract address as the thing that the application sees. But the really cool thing is that when you hit a button, normally what would happen if you're interacting with a dApp is you hit a button and it pops your wallet up, and you got to broadcast a transaction to kind of push the application into its next state. What Pilot does is essentially captures those RPC requests, spins up a fork of the chain, simulates the outcome, and then spoofs the result back to the application. So the application then can progress onto its next state. You can click another button, it'll do the same thing. Click another button, do the same thing, and you build up this kind of arbitrarily long set of a batch of interactions. You can then simulate the entire batch, be very, very sure of what the outcome is going to be, and then hit execute once, rather than having to broadcast separate transactions for each of these. And so this is really great. I think just as an end user, it means lower transaction fees and being much more concrete in what your outcome is going to be. But it's really, really useful in the case where you've got, say, 7 people that you've got to coordinate on a multi-sig. And it means like amortizing that effort of trying to wrangle everyone to sign into one transaction rather than every time you click a button. So it really makes kind of coordinating large multi-sigs much, much easier and much more auditable. So yeah, this is, I guess, an example of where we're going with the application side of things around Zodiac on top of the kind of base layer infrastructure that we built out there.
Yeah, and I know you're desperate to touch on it, and moving on then from Zodiac, suddenly Enclave was born. What was the purpose of Enclave, or what is the purpose of Enclave, and where was that born from? And I guess what's the problem you were trying to solve with Enclave?
Yeah, it's a bit of a departure, obviously, from what we had been doing with Zodiac, or like at face value seems quite different. But again, I talked about us being access control nodes, and it's born out of this same kind of base layer of problems. What we were originally looking to solve for was secret ballot voting. We've seen this kind of increase in the need for, but also the kind of desire for a lot more organizations, a lot more people kind of expressing an interest in or a want for there to be secret ballot systems on chain. And just like a bit of background there's a very good reason that every worthwhile democracy in the world uses a secret ballot. Right? Open ballots are very, very susceptible to bribery, coercion, collusion that ultimately distorts their outcomes. And so again, every worthwhile democracy in the world about 100 years ago switched to a secret ballot to kind of obfuscate this, to work around this risk of bribery and collusion, and to essentially maintain integrity in their system. On-chain voting is kind of a reversion from that point of view, right? It's taking this huge step backwards to fully public voting. And I think one kind of bit of nuance to understand there is that the challenge with secret voting in a traditional sense is you get very strong guarantees of privacy, but your guarantees around integrity or kind of correct execution, correct counting of the ballot is very, very trust-based, very opaque, and very, very manual and kind of bureaucratic and heavy. And so what we get out of on-chain voting is very strong guarantees of correct execution, at the cost of privacy. And so, yeah, what we're ultimately looking to solve for was getting both of those guarantees at the same time. How do we get strong guarantees around correct execution as well as strong guarantees around privacy? And there's been some significant work towards this over the last really couple of decades. Kind of secret voting systems, electronic voting systems have been worked on continuously, again, for the last few decades, but have always had one or several untenable trust assumptions for large-scale use cases. Generally, it boils down to either or both of integrity and privacy being a very trustful process, essentially relying on a trusted operator or some trusted hardware. And so we wanted to build a system that didn't have those kind of trust assumptions, that was able to ideally get cryptographic trust assumptions of both, and in reality get at least cryptographic assumptions of correct execution, and then be able to broadly distribute the guarantees around privacy. Very long-winded way of getting to here. So yeah, Enclave was originally us trying to think through how do we solve for secret ballots in a way that gives us these strong guarantees around execution and privacy. And in designing for that system, or for those outcomes, we arrived at this combination of technologies in fully homomorphic encryption, zero-knowledge proofs, and threshold cryptography. Each kind of doing or giving a different set of guarantees. So fully homomorphic encryption allows us to compute over data without having to decrypt it. So it means votes can be submitted as a ciphertext. We can compute over the ciphertext and then produce an output without ever having to see any of the inputs. Zero-knowledge proofs allow us to succinctly verify that each step in the kind of chain of operations happens correctly. So we can get cryptographic guarantees of correct execution of the entire process. And then threshold cryptography allows us to distribute trust in the keys that are ultimately the inputs and ultimately the output are encrypted too. And so combining the threshold cryptography with economic guarantees, we can have then very strong guarantees around the privacy side of the system. And yeah, I think the real light bulb moment for us then was realizing that voting is essentially an aggregation, and that there's a whole class of aggregation problems outside of voting that benefit from this same set of properties, that benefit from the ability to take an arbitrary number of private inputs, never have to decrypt them, but be able to compute over them and produce a verifiable output. So these are things. The other kind of beachhead application that we're looking at is sealed bid auctions. So they're another aggregation here where you have a bunch of bidders who want to submit bids but don't want to leak information. And ultimately what you care about is getting the price and the winner out of the machine, but not ideally you don't want to leak all of the other state. But then there's also a whole other class of use cases that are more to do with that are less concerned with integrity guarantees and are more concerned with liability and access benefits. So essentially being able to not having to take custody of data that you want to produce some insight from means that you either get better access to data because you can now run compute over data that you otherwise wouldn't have access to for liability or for legal hoop jumping reasons, or for because of privacy concerns, or allows you to again produce those same insights without having to take on the liability of taking custody of a bunch of third-party data. And so yeah, we're thinking about things like medical research, financial analytics, and yeah, this whole class of aggregations where you're dealing with a bunch of third-party data, or you're wanting to produce insights from a bunch of third-party data, but don't want to take custody of it and take on that liability. Yeah, I guess that's a good, quite deep picture of Enclave and how it came about.
Yeah, no, we've got loads of questions to follow up with there. I guess, first of all, I mean, you see a lot of examples of, I guess, ways where you could utilize zero knowledge proofs or different cryptographic protocols in more of a sort of real world environment, should we call it, or in a, in a Web2 setting. A lot of the ones that come up are always around sort of anonymous voting. Do you see that becoming very much commonplace in outside of Web3 or off chain? You've clearly got a use case for it there, and are we going to see this become more prevalent?
Yeah, I think so. I mean, I hope so. So again, the trade-off that traditional voting systems make is, at least like secret ballot systems make, is you trade guarantees around privacy for guarantees around correct execution, and I think the benefit that we're hoping that we bring to these type of systems is not having to make that trade-off, right? Or giving a third option where you get both strong guarantees of correct execution and strong guarantees around privacy in a digital setting that's fully auditable. And so, yeah, this is as applicable off-chain as it is on-chain. Voting is a huge class of problem and opportunity, from Girl Scout troops to global corporations and nation states and everything in between. And so, yeah, I think there's a really, again, massive opportunity space here for improving voting systems across the board, not just in organizational design. It's also a kind of critical protocol building block. Any system where you've got kind of diverse participants reaching consensus in some way likely has some flavor of voting implemented. And so, yeah, there's a really again, rich opportunity space there. The same is true for auctions. And then again, extending beyond these two kind of integrity-based use cases, there's that huge opportunity space for other access and liability-based value propositions in all kinds of other aggregations.
Mm-hmm. And another thing you touched upon is the cryptography under the hood. You mentioned FHE, ZKP, threshold cryptography. It's interesting. In my first episode as well, we had Payman from Fairblock say something similar in terms of maybe teams, and this might be purely anecdotally from the people I've spoken to, but more teams are maybe using a combination of these technologies. I think maybe a couple of years ago you had people, and maybe you still do, say, ZK is the end game, for example. But are we now in a world where it's actually more about using the right tool for the job, or using a combination of these tools? What are your thoughts on that?
Oh yeah, I mean, I think right tool for the job is absolutely the way to characterize it. For different classes of problems, different solutions are going to be appropriate. And yeah, I think where this combination of these three tools in particular is useful is where you're wanting to aggregate information. In that case, you have this need to be able to, again, distribute trust, to be able to do so verifiably, and still to be able to run the computation without having to unnecessarily unmask information. And so, yeah, this combination of tools, I think, is uniquely suited to these type of aggregation scenarios. But there are a bunch of other use cases that are still kind of privacy-centric use cases where that combination of tooling doesn't necessarily make sense. If you're not dealing with aggregations, then you potentially don't need the threshold components. If you're doing computations where you don't have where kind of each input has a discrete output that doesn't need to be masked, then you maybe don't need the FHE component. And so, yeah, like getting the right combination of tooling for any given use case is, I think, a really critical step here. And yeah, there's been a lot of I don't know, clickbait articles and Twitter Spaces and all this kind of stuff that are like, yeah, the end of ZKPs because FHE is kind of maturing and stuff like this, and yeah, it really is nothing more than clickbait, right? The reality of the situation is that these are all useful tools for building systems, and in most cases, you'll end up using some combination of them depending on what your requirements are.
And they always seem to be 3-letter acronyms, and you touched upon
Right.
another one, Encrypted Execution Environments. So what's that? It's a fairly new one to me. So what's that, and how are you working with Encrypted Execution Environments?
Yeah. So this is it's fairly new because this is one we coined and still trying to get out there. And it's really, we were kind of just riffing on the alternative in trusted execution environments, and so EEE versus TEE. It rhymes, and it's just a fun bit of wordplay. And then encrypted execution environment also then further condenses down into E3, which we thought was cool. But that's about it.
I'll let you have it.
Yeah. No, so it's really just us playing with nomenclature. The other one that we've been talking about is collaborative confidential compute. So another 3-letter algorithm, CCC, which is probably not a good one in the thinking about it now in the privacy and cypherpunk space, just because there's already was it Chaos Communication Conference, I think, has occupied CCC, but nevertheless, yeah, we do enjoy a good acronym as a space, and definitely internally at Gnosis Guild. But yeah, to I guess answer the question better, so encrypted execution environment is kind of how we're thinking about packaging this whole combination of components that a developer application builder would kind of interact with. So you have an entry point to request that some computation happens, and then there's a bunch of intermediate steps involving nodes in our protocol, as well as compute providers that are external protocols. But ultimately, you make a request, and then at some point in future, after a bunch of intermediate steps, it spits out a result. And so we're calling that all of the box that all those things happen in the encrypted execution environment. And that is really intended to be an alternate to trusted execution environments for a class of use case, and give kind of meaningfully different trust and costs profile to a trusted execution environment. The two are not mutually exclusive. I can definitely see some systems where both of them could be used in tandem for various components. Again, I think TEs are another one of these kind of privacy enhancing technologies that you should have in your toolbox when you're building systems. But yeah, I think there's a class of use cases where hopefully E3s will be a meaningful alternative to trusted execution environments, and yeah, we are working on I guess better communicating that.
Is it less hardware focused? I know TE is very hardware specific. Is
right.
different,
yeah, I guess
different to that?
Yeah, well, this is a good point of disambiguation. Yeah, so trusted execution environment, I guess for the uninitiated, is a hardware-based trust assumption. So you have essentially a separate segment of your computer that has that is kind of much more hardened. You have a processor and a memory segment that everything that happens within it is encrypted and isolated from the rest of the system, and basically relies on that hardware-based isolation, along with then an attestation chain from essentially the hardware manufacturer through its whole custody chain to however then you interact with that, whether it's directly or via a cloud provider like AWS. You get this kind of chain of attestations that you can then verify that the image that's running on this TE is what you think it is, and that given the certain inputs, it's produced this output and whatnot. So you get this, again, attestation-based trust assumptions around both privacy and correct execution. E3s, on the other hand, encrypted execution environments, are not hardware-based. It's based on cryptography and game theory. So we, depending on which compute provider, and I can dive into that in a moment, depending on what you use as a compute provider, you can get essentially end-to-end cryptographic verification of the correct execution of your program without any attestations from any custody or custody chain or manufacturer, and then economic guarantees around the privacy of the data that goes into it. So yeah, rather than trusting a hardware chain, you're trusting a cryptographic chain and a set of economic incentives for good behavior for the set of operators that are securing the inputs and intermediate states to that computation.
So go on, touch upon it then. How does that vary with different compute providers you just mentioned?
Right. So we have, within an E3, you have this kind of core process, essentially the computation that you want to run over the encrypted inputs. And that is going to run in what we call a compute provider, which is essentially just an address that's allowed to tell the protocol what the output is. And this could take on any number of different shapes. Ideally, it's something that is cryptographically verifiable. So something like a ZK virtual machine, things like RISC-0, Jolt, Succinct SP1. These are ZK virtual machines that let you run kind of arbitrary code and then prove the output of that computation based on whatever initial conditions you set up. And so, yeah, in the case of using a ZK VM as your compute provider, then you get this kind of end-to-end cryptographic verifiability of your E3. But not all computations will lend themselves well to running in a ZK VM, and so we've made this a kind of modular component to the system, and it could take on a number of other forms. It could be more of an optimistic virtual machine. It could be a run inside of a TE. It could be something that's run using, say, a committee-based consensus rule to decide what the output that gets published back to the execution environment is. Yeah, there's a variety of different kind of shapes and sizes of compute providers that essentially give you the ability as an application builder to trade off between cost and guarantees and scalability. And again, yeah, our preference is obviously to run inside of a ZKVM, but recognize that that's not a one-size-fits-all solution, and so it's I think it'd be necessary to have a variety of different options there.
Awesome. There was one question as well. We've just to skirt back a little bit. When you're describing way back around the use cases around Enclave, you mentioned around sort of anonymous voting, and one thing that you've shared with me before, a USP, I guess, of Enclave is how it remains receipt free. That's not something we've touched upon today. I think that would be quite interesting to share a little bit about, you know, what that means and how that differentiates Enclave from other projects.
Yeah, receipt freeness is this interesting property. So I first became, I guess, a bit more intimately aware of this thinking through the Macy project. This is the minimal anti-collusion infrastructure that Vitalik Buterin and Barry Whitehat, both from the Ethereum Foundation, proposed many years back now, and then was built out by the PSE team, Wei-Jie Ko, and a handful of others. It's essentially a voting system inside of a ZK circuit designed to enable receipt-free voting. And this receipt-freeness quality is, it turns out to be, I think, the really critical quality for legitimately anonymous voting if you want to be able to do it in a digital setting. Or I mean, I guess is the one of the critical qualities that is enabled by anonymous voting in a paper ballot setting as well, but has been historically very difficult to achieve in a digital ballot. And so the succinct kind of way to think about receipt freeness is, as a voter, I should not be able to generate a receipt that will convince anyone else of how I voted. If I can generate some kind of a receipt that is sufficiently convincing to someone else, then I can be bribed, coerced, colluded with to manipulate how I vote. This is really difficult in digital settings, because every time you produce something in a digital setting, you generally end up with a footprint that you can use as a receipt to enable collusion. This is particularly the case in ZK settings, where you're literally generating a proof of what you've done that you can then show to someone else. And so creating systems where you get both your guarantees of correctness from ZK, but eliminate your ability to share the proof of that guarantee with someone else is a really interesting challenge. And so this is kind of the whole problem that Macy was designed to solve for. It did so in a computational way, where within the circuit you had a way of, as a user, you had the ability to send multiple different types of messages, both a vote cast and this kind of key switching operation. And you could essentially do this key switching operation an arbitrary number of times, such that you create a kind of tree of votes that are potentially yours, and you can't prove to anyone else which of the leaves on that tree is you, or which one is the kind of valid vote. And so in doing so, you effectively make your votes receipt free. If we were trying to collude, I would not be able to show you a receipt from a vote and convince you that this one was valid and had not been invalidated by some key switch message earlier or later. The challenge, though, with this design is that it creates a whole bunch of internal logic inside of the ZK circuit, where you've got to then process that whole message tree and figure out which votes to count and which ones to discard. And so from our side, we've been working on doing similar things, but using cryptographic tricks rather than computational tricks. And the nice thing that we have on our side for this is that the FHE schemes that we're working with have this quality of ciphertext malleability, which essentially means like you can take a ciphertext and you can do computations on it and produce a new ciphertext without having to know what the pre-image was, what the plain text was for the original ciphertext. And so this allows us to do these kind of masking operations on those ciphertexts and build this receipt-free property in that way, rather than having to have a more complex circuit for tallying the vote.
Well, you've taken us on one hell of a journey from basketball to Gnosis Guild, to Zodiac, to Enclave. I'm sure there's something lined up. Have you got anything in the works? Have you got any new projects coming up? Is there anything we can expect coming out from Gnosis Guild imminently or soon enough?
Yeah. Well, I think that the biggest things that are kind of coming out from Gnosis Guild are around those two projects still. So Zodiac, I think we'll have some announcements coming up in the not too distant future around this, again, kind of unified, more unified interface for interacting with it. So yeah, excited to share more on that in the coming months. And then Zodiac is kind of ramping up towards a production launch. It's still relatively early days for it, but we have hopefully a test net coming online in the next month and a half, something like that. And then are aiming for a production launch either, I don't know, mid Q4 this year or maybe early Q1 next year, depending on how development goes. And so yeah, these are the big things that we're kind of looking towards right now. Beyond that, I think we're also looking to start incubating a few new ventures.
Mhm.
What they are yet, I'm not sure, but yeah, we've got some interesting ideas.
Well,
Always
keep
keen to
us
work on things,
posted.
but yeah, absolutely.
Awesome. Well, thank you so much for your time, Auryn. It's been an absolute pleasure. I've thoroughly enjoyed the conversation. Make sure you keep us posted with the latest launches, anything else we should check out. And it's been a pleasure to chat, and I'm sure we'll speak again soon.
Yeah, cheers, Ed. This was fun.
Awesome. Thanks, Auryn.